The three types of singularities. This video is part of a series of videos describing the entire universe. I am starting from the early stages of the universe before the Big Bang. I am discussing the various situations for the formation of the Big Bang singularity. Then the cause of Big Bang at that particular time is also explaining here. In this video series, I discuss the subsequent Big Bang, the expansion, the structure, and the end of the universe. I illustrate all this with the help of a new concept that I have developed from my studies. In this video, we will discuss the singularity that led to the Big Bang. We are discussing three types of singularities here. The Big Bang singularity, black hole singularity, and the third one is a new idea of mine. It is just opposite to the Big Bang singularity. I call it as space-time singularity. It is created at the center of the universe. So I can say that the expanding universe is going to another Big Bang. That may happen at any time. Let us see how it is creating. So what is a singularity? That is my prime question in this video. Singularity is a condition in which the absorbed matter is concentrated at the lowest volume or space. In physics, we can see two types of singularities. One is called the Big Bang singularity and the another one is black hole singularity. We can try to learn more about the singularity. Imagine we are traveling on a very busy bus. There will be a very little space inside the bus. On that journey, we will not be able to move as we wish. If a few more people get on the bus again, what will be your situation? In a singularity, the situation is even worse. The particles are so close together that they cannot even express their basic properties. It even lost its identity. Now, if we take an atom, we can know that there is a lot of space inside it. Almost 99.5% of an atom is filled with space. But when the same atom enters a singularity, its condition becomes another. It is very squeezed and the space in it is gone. What happens here to the space that once existed within an atom? The situation where electrons, protons, and neutrons become together. The atom lost all its fundamental characters such as strong interaction, electromagnetic interaction, and weak nuclear interaction, and showed only the gravitational interactions. Since neutrons and protons combine with each other and under the effect of singularity, there is no need for the force to bind them. So the strong interaction is unwanted here. And the electrons are also becoming part of the singularity. The other two fundamental forces are irrelevant too. What is happening to all these fundamental interactions? We have two situations before us. These basic forces can probably become part of the energy of a singularity. The next possibility is that they may remain in singularity as a unifying force along with the gravity. In any case, as far as with our present understandings, there is only gravity in the black hole singularity. But in the event of a gravitational collapse, there is a massive energy and space dissipation. So the four forces are more likely to combine into a single force. However, an atom inside the singularity is itself gone. For that atom, the time has ended, or a start to another situation. So it is the end of time, or does it continue in a different state? As part of the singularity, when the atom remains a new state, there is a new time begins for that atom. Big Bang singularity is not like the black hole singularity. There were no atoms or other particles at that time of the Big Bang unity. All these things were created after the Big Bang. It can only be said that there was energy and unified gravity as its property. The black hole singularity is caused by the collapse of gravity, which results in the end of the life of stars 4 or 5 times larger than the Sun. When the heavier stars are in their final stages, at the end of energy production with the nuclear fusion, by the effect of its gravity shrinks itself and become a black hole. What is meant by shrink itself? We can think this in two ways. When there is only energy left in a black hole, the space inside must be expelled. When one atom enters into a black hole, the electrons inside it combines with the particles in the nucleus and expel the space between them. Here is the next question. What happened to the space that is thus ejected? It should be added to the curved spacetime of the black hole. Then the amount of curved space under the control of the black hole will not increase. Does it not affect the gravitational field? Thus, I describe the evolution of the universe as part of the product of the interactions between spacetime and energy. The second situation is to try to shrink the space together with energy. The possibilities for that are very rare. Let us try to understand more about it also. Anyway, gravity increases when it decreases the size. Becoming smaller, its boundaries are more close to the center, and hence the gravity on its surface also increases. Small by itself, with its gravity, a black hole can control even light. We will see more about gravity in the later videos. All these situations are well described in my book, The Key to the Secrets of the Universe. You can see the evolution of the universe from the primordial stage until the destiny of the expansion of the universe in my book. There you can see a lot of new ideas on the expansion and the acceleration of the universe and about the gravitational interaction. I am explaining there how the expansion of the universe is undergoing another Big Bang. You can find the link to the book in the description box. So far, we have seen a black hole singularity arise from the stars. Now, let us see how a Big Bang singularity has evolved. We have to think seriously about the states of energy at that time. For this purpose, I have come up with an idea that emerged in my study of quantum gravity. The smallest quantities we know today are those on the Planck scale. And it is a dimensional model that focuses on the basic dimensions such as mass, time, and distance on the Planck scale. According to this idea, all the three dimensions like mass, time, and distance are having the same strength. As we all know, these three have different values in physics. Each of these is considered here as forms of energy. According to Einstein's theory, we know that the energy of an object is E is equal to mc square, where E represents the energy, m represents the mass, and c represents the velocity of light at vacuum. We know that the velocity is distance traveled by the time. Then we can write c in the form of L divided by t. Here L represents the distance and t represents the time. Now let us see how we can put all these things together on the Planck scale. We can now write this as Planck energy is equal to Planck mass into Planck length divided by Planck time the whole square. Here we can see the value of Planck length divided by Planck time is the same as the value of c. We have its own measurements and criteria to represent mass, time, and duration. I would like to see all these three items as different forms of energy. Imagine all three of these qualities, mass, time, and length, which we believe to be three different things. They have special criteria in physics and three different values accordingly. But beside the energy as a closed system, they have the same strength as a dimension. All these three are distributed in the same strength as forms of energy inside the atom or a particle. Let us treat a particle as closed system, where Planck length and Planck time are equal strengths. Then Planck length divided by Planck time is equal to 1. So we can say that the strength of C is also 1. In principle, the rest mass of a particle is equal to its energy. Since the strength of C is 1, the strength of C square is also 1. Here we are opening a new door. Energy can be located in two conditions. E is equal to mc square and E is equal to mc. The energy in the first state is familiar to all of us. Everything we see in our visible universe is this state of energy. In this case, the dimensional configuration of the energy will be m, L square and t raised to minus 2. The second situation, E is equal to mc, is a situation where we know nothing. The dimensional configuration of this state is m, L t raised to minus 1. In terms of the first condition, c square, and the second condition, c, we can imagine the ratio of the reactions. Planck length divided by Planck time, the interaction of energy is very negligible. Energy forms that exist in this state and which are less likely to interact with each other can be called as primordial particles. Our universe must be evolved from this state. This may be the universe that preceded Big Bang Singularity. The dark matter which we are looking may probably the energy particles in this state, the strength of fundamental units in energy. In this picture, all three basic dimensions are distributed as the same force within the energy. This is the state of energy that existed at the Big Bang Singularity and before. In the visible universe today, the distribution of the fundamental quantities within the energy is the form of m, L square and t raised to minus 2. Our universe is a lot wider than we recognize it now, and it is still expanding. I would like to call the state before the Big Bang also as the primordial universe. So the universe before the Big Bang must have been even bigger. The forms of energy that have been scattered over a very wide space converge into a singularity in a very small space. That is, the vast universe collapses into a singularity, which then begins to expand as it by the Big Bang. The universe has been expanding for billions of years since the Big Bang. Then how many billions of years will the universe take to get the moment that caused the Big Bang? Today we know how a star is born in a large molecular cloud. In that molecular cloud, the particles of energy are attracted to each other to form a very large structure, going through a very complex process, and it takes billions of years to become a star. If it took such a long time to form a star, how long would it take for the formation of the singularity, which is responsible for the entire universe contains billions of stars what we see today? Then we have to say that there was a time before the Big Bang. Presently, most scientists believe that there is no time inside the singularity. I do not agree with them on this point. Everyone can explain the time according to their own ideas. Anyway, here I am adding a picture from my thoughts to describe the states of the universe before the formation of the singularity. Now let us see how the universe evolved into a Big Bang singularity. In any case, only an unbalanced universe can travel to a Big Bang singularity. An equilibrium universe would never want to change its current state. In a fully equilibrated universe, all the particles of energy are distributed precisely at the same amount and same distance. It is not difficult to destroy the equilibrium. A slight change in the position or mass of any one of these particles will destroy the equilibrium. So to create change in an equilibrium universe requires the involvement of an external force. We will not find such a presence anywhere here. Anyway, we have a very unbalanced universe in front of us. So we can leave the idea of interference of an external force right here. Let us see what happens in the surroundings when two particles converge on each other. We can treat that these particles as the primordial forms of the energy. We know that inside a tiny bit of atom, a huge empty space in it, we can't even imagine. Such was not a case that the primordial particles. They were purely forms of energy. Inside it, the space had no relevance. So it was completely filled with energy. The basic forces we experience in the present universe, such as strong interaction, weak interaction, and electromagnetic interactions, was not included there. So these small forms are attracted to each other by their gravity, and they merge together to create larger structures. The space between them now can be seen to be more curved. Curvature proportional to the amount of energy is generated in that space-time. We can call this as the primordial interaction. When it grows and forms as a singularity, a large curvature of space-time is created so that even light cannot escape out. Unfortunately, there was no light at that period. Some of these particles merged each other and forms a bit large structures. It may or may not happen at many other places in the space at the same time. With the help of gravity, they attract to one another and thereby converge on a large structure. And then gradually it becomes a singularity. The formation of the Big Bang singularity. In addition to the picture we saw earlier, this picture is also created a singularity. In this picture we can see the red sphere as the singularity and the white cone as the distance to its even horizon. Another type of singularity is the space-time singularity, which we can see at the center of our present universe. At the center of the universe is the absorbed space that is under the extreme pressure and the energy within the gravitational frame that wraps it. If the Big Bang was caused by a singularity filled with energy and wrapped with its own space-time, the opposite things are happening here. What happens here is an interaction between space-time and energy that wrapped it. The current absorbed space at the center of the universe is in a similar state that of the Big Bang singularity. If energy was absorbed into the center of the universe when the Big Bang singularity was formed, then space is absorbed into the center of the universe here. If the value of time was 0 within the Big Bang singularity, then the time would be 0 here as well. But I don't believe that time will be 0 at any point. For me, time is always changing from one state to another. We can also call this singularity, the singularity of space-time. I hope you get an idea about the three types of singularities.